So for the first one up here, again, some of you may have used the method of, come on. Are we back? Okay, we're back. Some of you may have used the method of turning that minus into a plus and then changing the sign of every number in there. And if that's the way you did it, that's fine. I'm going to go ahead and set this up vertically, one above the other. So the x squareds under the x squareds, negative 8x under 3x, and the 4 ones under the negative 13 ones. And we are subtracting. So negative 13 minus 4 is a negative 17. Here's the really tricky one. 3x minus a negative 8. X is a positive 11x. 7x squared minus a negative 2 is a positive 9x squared. Now I'm going to pause there. Just a show of hands, how many of you had that one? Okay, any questions on how I got that? Or are the issues the negatives, or did you understand how to do the process and the negatives got you? Is there anybody that doesn't understand how to actually do the subtraction or combining? Okay, perfect. The next one, we're going to have to do distributing. I'm going to have to rewrite it so I have some space to work here. We have enclosing symbols with the parentheses. So we're going to start with the first one here. Is there anything to do inside this set of parentheses? No, right? Is there anything that needs to be done to that set of parentheses? Yes. So we're going to multiply by the 4x squared. 4x squared times 5x to the third is? Somebody be brave. 20. 4 times 5 is 20. And yes, x squared times x to the third is x to the fifth. 4x squared times negative 2x. Four times negative 2 is negative 8. X squared times x is x to the third. Remember, we think of that as x to the 1, so 2 plus 1 is 3. Our second parentheses down here, is there anything to do inside of those? No, anything to do to those. Yeah, times, that's not 3x, it is negative 3x. So negative 3x times 4x is, there we go, negative 12x squared. Negative 3x times the negative 5, positive 15x. Good. Are we done? No, what do we have to do yet? We're done, right? I thought I heard somebody say no, but we're done. That's it. Nothing more we can combine. If we had any that had the same power of x, there would be stuff we can combine, but there isn't right now. Any questions on that one? Okay, well then let's go on to number 3 here. I'm going to cheat and go ahead and use the FOIL method to make this a little quicker. So we've got the first. 5x times 3x is 15x squared. Outer or outside, 5x times 7. Positive 35x. Then the inner or inside, negative 2 times 3x is negative 6x. Yep. And then the last, negative 2 times 7, negative 14. Are we done there? No, not yet. We do have something we can combine here. What is it? 35x and the negative 6 or the minus 6x. So the 15 15x squared won't change. What's this combined to make? Yeah, positive 35 and negative 6 make a positive 29, so it's 29x and the negative 14. Any major questions on those? Okay. So then we talked about these things last week. What does that mean? Or last week, last class. It means whatever's on one side of the equal sign has exactly the same value as what's on the other side, right? So we can think of that as a balanced scale. X equals 7, X has exactly the same value as 7. Now, everything we do with this has to be done in such a way to keep that scale balanced. So anything we do to one side has to also be done to the other side so that it doesn't tip. All equations start out in this form as a variable equals a number. And they're built from there. So some things we can do to build onto it, well, we can use our basic operations. We have actually 6 basic operations that we've discussed, only 4 that we've done in detail. We have addition and subtraction. We have the multiplication and division. And then, of course, we have the exponents, or the powers and roots. We're going to kind of stay away from the powers and roots for now, but we are going to use the other operations. So if I wanted to build an equation, I start, like I said here, with a variable equals a number, in this case, x equals 7, and I perform one of those operations on it. Let's say we're going to add 4 to this equation. So x plus 4 is simply x plus 4. Now, this scale is going to tip unless I do what? Yeah, do the exact same thing to the other side. Add 4 to the other side. 7 plus 4 is 11. Perfect. So x plus 4 equals 11. So we have now built a more complex equation. Now, most of the time, we're not going to be asked to build the equation. We're going to be asked to do something called solving an equation. When we're asked to solve an equation, what it's asking us to do is to take that equation back apart and get it back into this form as a variable equals a number. Well, this equation was built by adding 4. How do we get rid of that? How do we reverse that? We subtract 4. So if we subtract 4, it takes that piece off, and we're back to just x. Now remember, this is still a balanced scale, so it's going to tip unless we do what? Yeah, do the exact same thing to the other side. We subtract 4 from the 11 to get 7. So we are back to a variable equals a number, x equals 7. So that is the solution to this equation. Now in this one, we built the equation, so we knew how it was built, so we knew exactly how to take it apart. The key to being able to solve an equation is being able to look at it and figure out how it was built. For example, we might have 7 equals y minus 5. To figure out how this was built, we find the equal sign right there. We identify which side of the equal sign has our variable on it. That's the y minus 5. And then we ask ourselves, what is keeping the variable from being alone on that side of the equation? Well, in this case, what's keeping y from being by itself? The 5. And what operation attaches the 5 to the y? Subtraction. So when this equation was built, what was done to the y, to the variable, was 5 was subtracted from it. How do we reverse that? Add 5. There we go. We add 5, it undoes or takes away that subtracting 5. So we're left with y. We added 5 to one side, we have to make sure we add 5 to the other side. 7 plus 5 is 12. So we get 12 equals y, or y equals 12. With these equations, one of the strengths, one of the conveniences, we can always double check the answer. The way we do that is we go back to the original equation, and we're going to replace the variable with the value that it's equal to. So y here is going to be replaced with 12. So 7 equals, instead of y, we're going to put in 12, minus 5. What is 12 minus 5? 7, right? So we have the same value on both sides of the equation. So it does balance. So that tells us that is the correct answer. 12 equals y is our correct solution. Any questions? Okay. So if we have 5z equals 55, we go through the process. Here's our equal sign. This is the side that has our variable on it. What's keeping the z from being by itself? The 5. What operation is attaching the 5 to the z? They're multiplied. When we have a number next to a variable like that with no operation or no symbol, it's implied multiplication. It's 5 times z. So how would we get rid of it? Divide by 5. If we divide by 5, it cancels out. Leaves you with z. Now, of course, by now we know we have to do the same thing to both sides. So we have to divide the other side by 5. What is 55 divided by 5? 11. So z equals 11 is our solution. We're going to double check it. Instead of 5z, it's going to be 5 times 11. And we have to see if that equals 55. Well, 5 times 11 is 55. Any questions so far? Okay. Of course, it gets worse. You guys will learn throughout the semester. I always make it worse. My job. We might have 3x plus 7 equals 25. So let's go through the process again. Here's our equal sign. Here is our variable. What is keeping x from being alone here, from being by itself on the left side of the equation? 3 and 7. What operation is attaching the 3 to our x? It's multiplied. The 7 is added, addition. If I'm looking at order of operations, which happens first, multiplication or addition? Multiplication. So when this equation was built, x was multiplied by 3 first. Then the 7 was added. So if I want to solve this, if I want to take it apart, I have 2 steps that I have to take off or have to reverse. Now, if you think about it, if you put something together, let's say you assemble a piece of furniture, you put together a toy for one of your kids, or you put together a model, you've just finished, you've just put on the last piece. If you have to take it apart again, what's going to be the first piece you take off? The last piece you put on. The same thing goes for taking apart an equation. Remember, solving is just taking it apart. So the first piece we remove is the last piece that was put on. So the last piece that was put on here was adding 7. So we are going to start by subtracting 7. That removes that piece. That leaves us with 3x over here. Now again, we have to do the exact same thing to both sides. So we're going to subtract 7 on the other side as well. 25 minus 7 is 18. Now what? We divide by 3. Good. The last piece is the multiplying by 3. We take it apart or we get rid of it by dividing by 3. We divide the 18 by 3 as well to get 6. Perfect. So we have x equals 6. We're going to double check that. 3x becomes 3 times 6 plus 7 equals 25. Well, we're going to combine just on the left side over here. 3 times 6 is 18. 18 plus 7 is 25. So we have the same value on both sides of the equation. Okay, so we might have one that looks like this. Where we 7 equals 2y minus 5. If we go to take this equation apart, what's the first thing we're going to have to do to solve it? Add 5. Good. So that takes that off. We're going to add 5 over here. All that's left over here with the minus 5 gone is 2y. What's 7 plus 5? 12. So 12 equals 2y. What's next? Divide by 2. Good. So that 2 cancels out, leaves us with y. What's 12 divided by 2? 6. Good. So y equals 6. That is our answer. We could stop there. I'm going to double check it quick just to be sure. So 7 equals 2 times y becomes 2 times 6 minus 5. Well, the 7 isn't going to change. 2 times 6 is 12. Minus 5 is 7. So we have 7 on both sides. So that tells us that that answer is most likely correct. Either it's correct or we made 2 mistakes that ended up happening to work out. I'm going to have you guys try a couple on your notes quick. 5x minus 1 equals 34. And 17 equals 3y plus 2. I'm going to try to solve those quick. We'll talk about them in just a minute. Okay, let's see how you did on these so far. So for the first one here on the left, what do we do first? Add 1. Cancels that out. We add 1 over here. So we get 5x equals 35. What's next? Divide by 5, which gives us x equals 7. We could double check that by putting 7 back in here for x, and it does work out to be 34. Over here on the second one, what do we do first? We'll subtract 2. Good. What do we get after that? 15 equals 3y. Good. And next, divide by 3. So y equals 5. Okay, any questions on those? Okay, well, our next step is to look at questions like this. So on this one, we find our equal sign. We try to identify which side the variable is on. And it's on the left, but we notice the x appears twice. We cannot solve an equation if the variable appears twice. So before we can start to solve, we have to get it down to where the variable only appears once. So to do that, we think of that balanced scale. In this case, the 3x and the 2x are both on the same side of the scale. So if I were to just take them and push them together in one big pile, would that change how my scale balances at all? No, it won't. So I'm just going to do that. 3x and 2x make 5x. We still have the plus 7. That equals 32. Now it's just like the ones we just worked on. What do we have to do next? Subtract 7. 5x equals 25. And then divide by 5. So x equals 5. Good. Now we can go back and put that in and make sure this works out. So 3x becomes 3 times 5 plus 7 plus 2x will become 2 times 5 equals 32. So no enclosing symbols, no exponents. Multiplication, division, we're going to go left to right. 3 times 5 is 15. Notice I'm only working with what's on the left side of the equation. I can simplify or combine one side of the equation. I don't have to worry about the other side. Well, we still have the 2 times 5, which is 10. And then 15 plus 7 is 22. And 22, get back here, plus 10 is 32. So we have the same result, same value on both sides of the equation. So we know that answer is correct. So what this example shows us is that we can take anything that's on one side of the equation and combine or simplify it however we need to before we solve the equation. We can have something pretty ugly like this, and we can go ahead and solve that. So before we start taking it apart, we have to get it down to where the variable appears once. So thinking of that balanced scale again, we have the two sides of the equal sign. We can take what's on that left side and we can simplify it just like we would any other algebraic number. What can we combine over there? 5x and 3x to make 8x. But we can also combine -7 and the +4 to make -3. Good. Now it's 8x minus 3 equals 7. It's in a form we can solve. What would we do first? Add 3. So now 8x equals 40. And then divide by 8. Good. So x equals 5. And again, we could go back and replace x up here with 5 and make sure we get 37 on this side to balance the 37 on that side. It's going to if you want to double check it. I'm going to have you guys try one in your notes. Give that one a shot, and we'll talk about it in just a minute. Okay, so what do we have to combine in this one? 7x and negative 4x make 3x. Good. What else? 2 and 5 make 7. Now, what do we have to put in there? It's positive 7, so we have to put in a plus. Still equals 40. What's next? Minus 7. That gives us 3x equals 33. And then divide by 3. X equals 11. This next one's going to look slightly different. When we look at this one, the variable still appears twice, but what's different about it? It's once on each side. Good. Here's our equal sign. We go to find which side has the variable on it, and the variable appears on each side. Now, being on opposite sides of the equation, opposite sides of the scale, if you will, we can't just push them together into a big pile anymore. They're not with each other. They're not together anymore. They're separated by the scale. So we can't combine them that way. But we still can't solve until we get this equation down to just the variable appearing once. So what we're going to have to do is just get rid of one of them. It's usually easiest if we get rid of the smallest one. So which one's smallest? The 4x. So that's the one we're going to get rid of. In math, the way we get rid of something is subtract it. Or if it's negative, we can add it. We subtract 4x. We take it away. It is now gone. We just have 7 on that side of the equation. But as we said before, to keep this scale balanced, anything we do to one side, we must also do to the other side. So we have to subtract 4x from over here somewhere. Where's the only place we can subtract 4x from? The 6x. Good. 6x minus 4x is 2x, and we still have the minus 9. Now this is in a form that looks familiar to us. What do we do next? Add 9. What's that give us? 16 equals 2x. Good. The 9 is gone there. And then divide by 2, which gives us 8 equals x. So again, we can double check this one. Replacing x with 8, 4x would become 4 times 8 plus 7 equals 6x would become 6 times 8 minus 9. And now, just like we did when we combined stuff, we can work on each side separately here. So we're going to work on the left side here first. 4 times 8 is 32. 32 plus 7 is 39. On the right side, 6 times 8, 48. 48 minus 9 is 39. So we get the same value on both sides, so it does check out. That solution, x equals 8 or 8 equals x, does work. It's a solution to this equation. It gets a little trickier when we have something like this. When we look at this one, again, the variable appears on both sides of the equation. We need to get rid of one of them. Which one's smaller? It's not a 2x, it's negative 2x. To get rid of it, it's already negative, so we can't subtract it. We're going to have to add it. So we add 2x, makes the negative 2x. Negative 2 plus 2 is 0, right? So it cancels that out. That leaves us with just the 34 on the right side. What else do we have to do? Add 2x to the other side, and yes, we have to add it to the 5x. 5x plus 2x is 7x. So now we have 7, and of course the negative 8 is still there. So we have 7x minus 8 equals 34. What's next? Add 8. 7x equals 42. And then divide by 7. X equals 6. We can put that back in and double check. Both sides will come out to 22, I believe. Let's have you guys try one in your notes. Never try that one. 18 minus 3x equals 2x minus 7. Tell me what to do. We could subtract 2x. What do we get? $18 minus 5x equals negative 17. What would we do from there? Well, the x is over here, so we got to get that by itself, right? So we subtract the 18. Negative 5x equals negative 35. And then divide by negative 5. X equals 7. That way works just fine. As you can see, if we do it that way, we work with some negatives. Negatives, maybe a little ugly. If you're good with them, great. It really doesn't matter which one we get rid of. If you don't like working with negatives, I would advise you to get rid of the smaller one first, which would be the negative 3x. We would get rid of it by adding 3x. That's gone. 18 equals 2x plus 3x is 5x and the minus 17. And then add 17. 35 equals 5x. And we divide by 5. Perfect. So 7 equals x. So we get the same answer either way. The reason I always suggest getting rid of the smaller one is so that we don't have to work with the negative. But if you're good with negatives, it doesn't make a difference. Okay, the next step is we can run into things like this. Of course, what's here that draws our attention? The parentheses. And like we've said before, anytime we see parentheses, it should scream at us, do something here first. As always, we look inside the parentheses. Is there anything that can be done inside there? No. What's our second question? Anything that needs to be done to the parentheses? There is, the times 3. We need to distribute the 3. So if we distribute that 3, what do we get? 15x minus 6. Good. 3 times 5x is 15x. 3 times negative 2 is a negative 6. Equals 24. What do we do with that? Add 6. 15x equals 30. And then divide by 15. X equals 2. For the sake of time, I'm just going to put this one side by side and let you guys try one. 5 times 2x minus 7 equals 55. Try that one in your notes. We'll talk about it. Where do we start? Okay, we distribute the 5. 5 times 2x is 10x. And then 5 times negative 7 is minus 35, or negative 35. Of course, this is still 55. What's next? Add 35. We get 90 equals 10x. That 35 is gone. And then divide by 10 to give us 9 equals x. Perfect. And as always, we could go back and put that 9 in for x and make sure we get the same value on both sides. At this point, I'm not going to do that anymore because I'm assuming you guys can deal with that. I'm guessing you're getting a little tired of seeing it by now. So it is almost 4:20, time for our break. It's 4:19, so let's come back in 10 minutes at 4:29. Let's see how you're doing on this one. As we mentioned before, we can work on each side of the equal sign separately to simplify and combine. So let's do that. On the left side here, we have several enclosing symbols. We're going to follow our order of operations. So we're going to go left to right. So we hit this one here first. Is there anything to do inside that one? No. In fact, if we look through the problem, there's nothing we can do inside any of the parentheses. So we can skip that part of it. We do need to do something to each of them. And this first one is going to be multiplying by the 3, distributing the 3. When we distribute the 3, what do we get for that parentheses? (6x plus 3). Perfect. For the second one, this one is multiplied by -5. What do we get when we distribute the -5 through that parentheses? Perfect, -15x plus 35. Now there's still stuff we can combine on the left side, so let's keep doing it. We can combine 6x and -15x gives us -9x. Perfect. We have 3 and 35 give us +38. That's all we can combine on the left side. So now we're going to go over to the right side. First parentheses, again, there's nothing we can do inside any of them. So we're going to distribute the 2. When we distribute the 2, what do we get there? 6x minus 8. There we go. The next parentheses, there's a -5 that we need to distribute again. What do we get when we distribute the -5 there? Perfect. -10x plus 25. Now we can't forget our +1 on the end over there. So now what can we combine there? X's. 6 and -10x make -4x. Then we can also combine the whole numbers, the ones. Negative 8 and 25 make, negative 8 and 25 would be 17, right? Plus 1 would be 18, so positive 18. Now, when we look at this one, the variable, the x, appears on both sides again. We need to get rid of one. Now, they're both negative. So which one is actually the smallest one here? The negative 9. How would we get rid of it? We would add 9x. So that's gone. We're going to add 9x over here. So we have 38 equals, what do we get on the other side? Negative 4x plus 9x is 5x, and we still have the plus 18 there. Any questions so far? So what's our next step? Subtract the 18, good. So 20 equals 5x, and then divide by 5. 4 equals x. So 4 equals x, we could go back and put that back in and make sure it works. We're not going to, but I'm trust that you can do that. I just don't feel like going through that effort right now. That sounds horrible, doesn't it? Okay. Our next thing we need to look at is what I consider to be the most difficult. I mean, working with negatives and fractions is up there, but I consider this to be the most difficult task in math, and that is translating words or a situation into numbers and symbols. So we're going to start out with something simple like a number increased by 7. To express that in symbols, we first have to represent the number. That number is going to be represented with a variable. That can be any letter. Most of us are used to it being either an X or an N in this case. Whatever letter you want to use is fine. So we could use P if we want to. How do we express increased by 7? Plus 7, right? So P plus 7 could be X plus 7, Y plus 7, N plus 7, whatever letter we wanted to use for that variable. There are a lot of other ways that we could have written a phrase that would also be P plus 7 or whatever variable plus 7. We could have 7 more than a number. That would be 7 more than something means 7 is being added to it. So the number plus 7 again. Can you think of any other ways, any other phrases that would give us P plus 7? I'll give you an easy one. A number plus 7. That's too obvious, yeah. Any others? Okay, added, we could say 7 added to a number. This next one's a little technical, but it's an important one. The sum of a number and 7. Sum means the result of an addition problem. That implies we're going to add the number and 7. And there are probably several others that we could come up with if we took the time to keep thinking about them, but let's move on. Now this next one is a little tricky. For less than a number. If we are 4 less than something, how do we get to that? Let's say you have $7 in your pocket today. Tomorrow you have 4 less dollars. How many dollars would you have tomorrow? 3. How did you get to that? 7 minus 4, right? You subtracted 4 from it. So 7 less than a number, we find, or sorry, 4 less than a number, we find that by subtracting 4. And of course, we have to represent the number. What letter do you want to use for the number? N. That works for me. So n less than 4, or n minus 4, sorry. N minus 4 is 4 less than a number. Now, a little side note here, a very subtle difference would be this phrase: 4 is less than a number. That very little word is has a very big impact here. 4 is less than a number would be this: 4 less than symbol a number. That's not what we're talking about here. For what we're going to do in this class, we're not going to do anything like that with less than or greater than symbols, because we're trying to represent things that we can put into an equation later and use to solve. Well, other ways that we might express, or other phrases that might express n minus 4, I go with a number reduced by 4. Anybody think of any others? A number minus 4, perfect. Number minus 4. Four subtracted from a number. Keeping with our last one from our addition up here, does anybody know what the result of a subtraction problem is called? The difference of a number and 4. That word difference is going to be important for us in a little bit as well. Another side note up here. 4 less than a number is n minus 4. 4 is less than a number was that slight variation. How would this change things? 4 less a number. Well, that one is actually saying 4 minus n. So if we had a number less 4, that would be n minus 4. 4 less a number would be 4 minus n. Let's move on. A number repeated 5 times. What's that going to look like? 5 times whatever our number is, right? We'll go with x. 5 times x. We don't have to have the 5 in there, so it could be just, or the don't have to have the times in there, so it could be just 5x. Any other phrases you can think of that might give us 5x? I'll give you the obvious one. 5 times the number. A number multiplied by 5. For some reason, multiplication always seems to be the hardest one for me to think of, even though it happens so often. Sticking with the spirit of the last two, the product of, and it doesn't matter whether we say a number, some spacing in there, a number and 5, or if we said 5 and a number, it doesn't make a difference. But again, product is the result of a multiplication problem. If I put a number split 3 ways, what's that going to look like? Somebody be brave. N over 3. You're right. N over 3, you could write n divided by 3 would be acceptable as well. Usually we do use n over 3 as our notation. Can you think of any other phrases that would be represented as n divided by 3 or n over 3? A number over 3, perfect. Any others? Number divided by 3, perfect. That was actually exactly where I was going to go. Number divided by 3. This is a little awkward, but 3 into a number. Keeping with the spirit of the last ones, the result of a division problem is a quotient of, now here we have to say of a number and 3. The number has to go first because it's the number divided by 3. So when it's as simple as a single thing being done to our variable, it's relatively simple to find. Where it's a little more complex is when we have something like this. 4 times a number increased by 7. What is that going to look like if I put it into symbols? 4x is 4 times a number. Increased by 7 is plus 7. Perfect. Seven more than 4 times a number. What's that going to look like? Nope, 7 plus 4x. Or 7 more than, we could have 7 plus, or we could have 4x plus 7. Either one of those is acceptable. So it's really saying the same thing, just a different way. Yeah, what the heck. The product of a number and 7 increased, product of a number, yeah, and so number and 7 increased by 4. What's this one look like? What's the product of a number and 7 mean? Multiply. So either x times 7 or 7 times x. Now again, you could use any letter you want in these. Increased by 4 means plus 4. So I just switched around where the numbers were. This next one is a very subtle difference from these first two, but it's a very important difference. Four times the sum of a number and 7. Now up here, this was 4 times the number increased by 7. Down here, it is not 4 times the number, it's 4 times the sum. How is that going to change things? Well, 4 times the sum is the result of an addition problem. So 4 times the sum implies the addition problem is already done. How do we make the addition happen before multiplication? Parentheses. So the sum of a number and 7 is x plus 7. So when it says 4 times the sum, since the sum is the result of an addition problem, it implies the addition had to happen first before we multiplied it. If I give you 5 times the difference of a number and 3, and I'm going to give you 8 less than 7 times a number. Now, since my math lab is going to do this to you, my math lab can't recognize any letter as a variable. It gives you a specific one. So I'm going to tell you for this one, let's use y as your unknown number. On this one, I'm going to tell you to use m as your unknown number. So go ahead in your notes and write a expression, symbols for each of those. So for the first one, 5 times the difference. What's the difference again? Result of a subtraction problem. So that implies the subtraction happened first. So the difference of a number and 3, how do we express that? It says the number first and then 3, so it's going to be y minus 3. What do we still need? 5 times. Perfect. Down here, 8 less than 7 times a number. 8 less than means 8 is subtracted from something. 7 times a number is going to be expressed as 7m. Good. In my math lab, make sure you're careful to use the letter they tell you to, otherwise it does mark it wrong. It can be frustrating. There were some frustrations this last week, by the way. Problems that were entered, a few of you had issues. You entered the right answer in my math lab, but the way you entered it, my math lab didn't recognize it and counted it wrong. On homework, don't worry about it. Your homework is graded for effort. So as long as you completed the question, I will look through it when I transfer the grades and I'll see you had it right. Even if it does mark it wrong, it's not a big deal, because as long as you have more than 80% on the homework, you're going to get full credit just for doing it. To me, homework's a learning experience. On a quiz, if it does that to you, you had the right answer, but it just didn't recognize it, let me know, and then I'll make sure I change those grades on the quiz. Back to writing these things out. So the next thing then is going to be looking at writing these expressions from an actual situation. The tough part at the basic level is most of the problems that we would have to write one of these expressions or equations for are so simple we could solve them without an equation. But in order to build up to a more complex problem, we have to start out simple. So we might start out with something simple like let's say your total earnings can be estimated as 4 times your tax. Find your tax in a year where, let me get that spelled right, where your total earnings is $44,000. Now, again, I'm assuming most of you look at this and you see, well, we're just going to take 44,000 divided by 4, and that would be our tax. But we want to practice writing an equation. So it's probably easiest if we don't even look at this last part. The first part here defines the equation we're going to write. Your total earnings can be estimated as 4 times your tax. So I'm going to let E be earnings, T be tax. E is equal to 4 times my tax. So as I mentioned, it's sometimes easier if you ignore the numbers first, pretend those aren't even there, and write the equation before you even look at them. Now, our total earnings is 44,000. What does that go in for, E or T? Earnings is E. So 44,000 equals 4T, or 4 times T. Now we solve that equation by doing what? Divide by 4 to get T by itself. 44,000 divided by 4 is 11,000 equals T. So your tax is approximately 11,000. We could look at pay. Let's say your wage is $13 per hour. Now, before I even write out the rest of this problem, what we know about wages, we know that our total pay is equal to our wage, in this case $13 per hour, times the number of hours. So now let's finish writing out the question here. How many hours do you work to earn $403? Where's this 403 going to go? P, that's your pay. Now we know you don't receive that. This is gross pay, obviously. But the 403 does go in for your pay. Then what do we do? To find the number of hours, we would divide by 13. So that's 8. 403 divided by 13. Is that 31? So that's 31 hours. We need to make sure we go back and answer the question. On all of these word problems, that's one of the most important steps, is going back and making sure what you have done answers the question. The question is, how many hours do you have to work to earn $403? Yeah, 31 is the answer, 31 hours. It can get a little more complicated than those. Those are word problems where we have basic formulas that we're kind of familiar with. We're familiar with wages. We're familiar with taxes and earnings and stuff like that. We could do like velocity, speed and stuff like that, where we have those formulas. But I want to now take a little bit of time of looking at a situation where it maybe isn't so obvious. It isn't a set formula that we're used to. For example, let's say that Frank sells 3 times as many cars as Tim. They sell a total of 56 cars. How many did each sell? So we have a total here. These problems are usually, if we don't have a set formula, problems come in one of 3 kind of standard things. Either we have one item is equal to another, we have the 2 items add up to give us a total, or the 2 items subtract to give us a difference. In this case, we have a key word here, total. So this is saying the 2 things add up to be a total. The 2 things we're looking at, Frank's sales and Tim's sales. So Frank's sales plus Tim's sales equals 56 cars. Looking at this right now, though, we would have 2 variables, Frank and Tim's sales. We can't deal with that. We can only solve equations with 1 variable. So there has to be a relationship between Frank's sales and Tim's sales. And that's right here. Frank sells 3 times as many cars as Tim. If I were going to express that, I would say Frank equals what? Three x, 3t, whatever you want to express it, right? We'll call it 3t for Tim. Frank is equal to 3 times Tim. What this means is we've defined Frank's sales is 3 times Tim's sales. Tim's sales is just his own. It's just going to be T. So looking up here, Frank's sales would be 3T. Tim's sales would be T equals 56. Now remember from last class, when you have a variable like this with no number in front of it, that's really a 1T. So before we solve, we're going to combine. 3T plus 1T is 4T equals 56. And then we divide by 4. T equals 14. Now we have to make sure we answer the question. The question up here is, how many did each sell? T equals 14. That's Tim's sales. Tim sold 14. Frank was 3T. 3 times 14 is 42. Frank sold 42. So we have to make sure we answer the question once we've solved our equation. I think you guys have had enough for tonight. There's a new quiz. This will be quiz number 2. It'll be due tomorrow. That'll be Friday at 11:59 p.m. There's going to be a new homework. That's homework 3, due for Tuesday. And I'm going to warn you, Unit 1 test is coming up next week, Thursday. So 1 week from today is our Unit 1 test coming up. I'll give you guys the last 15 minutes if you want to work on homework or if you want to work on the quiz. That's up to you. I will be here until at least 5:20 to answer any questions you might have.